Hello students, welcome to lecture 3 of S Black Group 1 elements. In previous lecture, we discussed about chemical properties of Group 1 elements and uses of Group 1 elements. Now our topic, general characteristics of alkali metals compounds. In that, the first one, oxides and hydroxides. On combustion in excess of air, the lithium can form monoxides, means the lithium react with oxygen, so then the lithium can form monoxide Li2O. The lithium also can form some peroxides Li2O2, and sodium forms peroxides Na2O2. The sodium react with air, then it can form sodium peroxide. And the sodium can also form some superoxides NaO2. And the stability of peroxides and superoxides increases with increase in the size of cation. For example, if you go from lithium to cesium, the size of the cation increases. Then the stability of peroxides and superoxides increases from lithium to cesium. So cesium peroxide is more stable and lithium peroxide is least stable. And oxides react with water to form hydroxides, crystalline solids. Hydroxides, crystalline solids. Let me take that reaction. The monoxide, general formula M2O. So it is a monoxide. And this monoxide is a colorless. So this colorless monoxide react with water. Then it will give hydroxide MOH. And balance that equation. Here two metals. So let me take here 2 and 2 oxygens, 2 oxygens, 2 hydrogens, 2 hydrogens. So the monoxides react with water to form metal hydroxides. And also that peroxides M2O2. It is a peroxide. And it is also colorless. So this colorless peroxide react with water. Then it will form hydroxide, metal hydroxide plus hydrogen peroxide H2O2, and balance that equation. So here two metals, let me take here 2, and hydrogens 2 plus 2 4. So let me take here 2 4, and oxygens 2 plus 2 4, and here 2 and here 2. So it is a balanced equation. And next, superoxide, the general formula MO2. So this superoxide react with water, then it will form metal hydroxide plus hydrogen peroxide plus oxygen, and balance that equation. So take here 2, and here also 2, and here 2. Now it is the balanced equation. And here it is a superoxide. And this superoxide is yellow or orange color. The yellow or orange color superoxide react with water, then it will form metal hydroxide. So here the oxides of first group metals react with water to form hydroxides, and these hydroxides are crystalline solids. So this is about oxides and hydroxides. Next one, halides. The alkali metal halides are colorless crystalline solids. The alkali metal halides general formula Mx. M means metal and X means halogen. For example, lithium fluoride or lithium chloride, lithium bromide, lithium iodide, like that, or sodium chloride, sodium bromide, like that. So that alkali metal halides are colorless crystalline solids and they are having high melting point. They are having high melting point and enthalpy formation of fluorides values decreases in the group. If you go from top to bottom, means if you go from lithium to cesium, the enthalpy formation of fluorides values decreases, means lithium fluoride to cesium fluoride, the enthalpy formation values are decreases from lithium fluoride to cesium fluoride, and enthalpy formation values decreases from fluorine to iodine. So the enthalpy formation values decreases from fluorine to iodine, and the melting and boiling points of halides decreases from fluorine to iodine. Melting point and boiling points of halides decreases from fluorine to iodine. So the fluorides having more melting and boiling points than chlorides, and the chlorides having more melting and boiling points than bromides, and the bromides having more melting and boiling points than iodides. So the melting and boiling points of halides decreases from fluorine to iodine. For example, if I take lithium halides, so here we are taking lithium fluoride, and here we are taking lithium chloride, and here lithium bromide, and here lithium iodide. So the lithium fluoride having more boiling point and more melting point than lithium chloride, lithium bromide, and lithium iodide. So the lithium iodide having less melting point and boiling point, and the lithium fluoride having more melting point and boiling points, and all halides soluble in water, but the lithium fluoride having low solubility in water. Low solubility in water. The lithium fluoride less dissolved in water due to high lattice enthalpy. Due to high lattice enthalpy and low solubility of cesium iodide. The cesium iodide also less soluble in water due to smaller hydration enthalpy. Due to small hydration enthalpy, and the remaining all halides are soluble in water, but lithium fluoride less soluble in water due to high lattice enthalpy, and cesium iodide less soluble in water due to smaller hydration enthalpy, and other lithium halides are soluble in ethanol and acetone. and lithium chloride soluble in pyridine also. So these are the halides of first group elements. Next one, salts of oxo acids. Oxo acids, those in which hydroxy group and oxo group are attached to the same atom. For example, there is a atom. To this atom, there is a OH group which is directly attached to A atom, and there is a oxo group which is attached to A atom. Now it is called oxo acid. The oxo acids, those in which hydroxy group and oxo group are attached to the same atom. For example, carbonic acid, H2CO3, carbonic acid. So in this carbonic acid, so there is a center atom carbon, and to this atom there is a OH group, and here double bond O, and this side OH. So H2CO3. So in this OH group and oxygen group directly attached to the same, so that's why it is called oxo acid. Carbonic acid is a oxo acid. Next, sulfuric acid, H2SO4. So sulfuric acid also oxo acid. So if you see that structure, sulfur is the center atom, and double bond O, double bond O, OH and OH. So H2SO4. So here in this compound, the OH group and oxygen group directly attached to the same atom. So that's why that sulfuric acid also oxo acid. Carbonic acid and sulfuric acid, both are oxo acids. And the alkali metals can form salts with all oxo acids. So the alkali metals means first group metals react with oxo acids to form salts. For example, I am taking sodium metal. So that sodium metal react with carbonic acid, H2CO3. Then it can form solid, sodium carbonate plus H2, and balance that equation. Here 2 sodiums, let me take here 2. Now it is a balanced equation. So it is a salt. And also that sodium can form bicarbonate. Sodium react with carbonic acid, H2CO3. Then it can form the salt of sodium bicarbonate, NaHCO3 plus H2. So let me take here 2, and here 2, and here also 2. Now it is a balanced equation. So the sodium can form salts, so it is also salt. Sodium bicarbonate is also salt. So the alkali metals react with oxo acids to form salts. And if you go from top to bottom in a group, for example, I am taking a first group, lithium to cesium. So first element lithium, next sodium, potassium, rubidium, cesium. So if you go from lithium to cesium, the electropositive character increases. Electropositive character increases. Then the stability of carbonates and hydrogen carbonates increases. Hydrogen carbonate means bicarbonate. So carbonates, the stability of carbonates and bicarbonates increases. If you go from top to bottom in a group, the electropositive character increases. Then the stability of carbonates and bicarbonates increases. but the lithium having less size, so it cannot form stable carbonate and hydrogen carbonate. The lithium having less size, so due to that less size, it having a less electropositive character, so it cannot form stable carbonate and stable bicarbonate. So here, for example, if I take a sodium carbonate and cesium carbonate and sodium bicarbonate, cesium bicarbonate. So here, if you go from top to bottom in a group, electropositive character increases. So the cesium electropositive character is more than the sodium. So the stability of sodium carbonate and sodium bicarbonate less than the cesium carbonate and cesium bicarbonate. So this is about salts of oxo acids. Next one, anomalous properties of lithium. Anomalous properties means different properties. So we know that the elements which are belongs to the same group, that elements can have same properties. For example, if I take first group elements, alkali metals, lithium, sodium, potassium, rubidium, cesium. So these elements belongs to the same group, that is group 1. So these metals should have same properties, but the lithium having different properties than the remaining metals. So here we are going to learn about that anomalous properties of lithium. So the anomalous behavior of lithium is due to number 1, small size of atom or ion. Small size of atom or ion. And second one, high polarizing power. High polarizing power. As a result, covalent character increases. So already we discussed that in reactivity towards halogens, that lithium halides having somewhat covalent character, and the remaining halides means from sodium to cesium having ionic character, and lithium is much harder. The lithium is much harder. And the remaining metals from sodium to cesium, the metals are soft metals. And lithium is least reactive. The lithium is least reactive and strong reducing agent than other alkali metals. Strong reducing agent. And lithium forms monoxides, Li2O, and lithium nitride. But the other metals from sodium to cesium cannot form monoxides and nitrides. And lithium cannot form hydrogen carbonates, but the other metals can form the stable hydrogen carbonates and stable carbonates. And lithium cannot form ethynide with ethine, but other alkali metals can form the ethynides. From sodium to cesium, the metals can form the ethynide with ethine. And on heating, lithium nitrate LiNO3. On heating, it can give lithium monoxide Li2O plus NO2 plus O2. So let me take here 2 and the lithium's 4. So let me take here 4 and nitrogen's 4. So let me take here 4. Now it is a balanced equation. So here it is a lithium nitrate. On heating, the lithium nitrate can give lithium monoxide, but other metals can give nitrides. Let me take sodium nitrate NaNO3. On heating, it will give sodium nitrite NaNO2 plus oxygen. So it is called nitrite and it is a nitrate. So lithium nitrate can give lithium monoxide, but other metals from sodium to cesium, other metal nitrates can give the nitrides. And lithium fluoride and lithium monoxide are much less soluble in water. Less soluble in water. So these are the anomalous behavior of lithium, means different properties of lithium than the remaining metals which are belongs to the same group. Next one, diagonal relationship between the lithium and magnesium. Lithium is the first element of the first group and magnesium is the second element of the second group. So here the lithium shows diagonal relationship with the magnesium, means similarities, similar properties. The diagonal relationship nothing but similarities between the first element of first group and second element of next group, called diagonal relationship. The similarities between the first element of the first group and second element of the next group, called diagonal relationship. Let me take first group. The first group elements lithium, sodium, potassium, rubidium, cesium, and next group is the second group. So the second group elements are beryllium, magnesium, calcium, and so on. So here the first element of the first element is lithium, and second element of the next group means second group, and second element is magnesium. So these two metals are having same properties, then it is called diagonal relationship. So the similarities between the first element of the first group and second element of the next group is called diagonal relationship. So the reason for diagonal relationship is having the same size. For example, I am taking atomic radii and ionic radii. Atomic radii and ionic radii. So here the lithium atomic radii is 152 picometer and magnesium atomic radii is 160 picometer. Approximately similar atomic radii. And ionic radii, so here I am taking lithium plus ionic radii 76 picometer and magnesium plus 2 ionic radii is 72 picometers. So the lithium and magnesium having approximately same size. So that's why these two metals shows the diagonal relationship and also having same electronegativity. So the reason for diagonal relationship is having same size and same electronegativity. And both lithium and magnesium are harder. In first group elements, lithium is hard, remaining elements are smooth. In second group elements, magnesium is the hard and the remaining metals are smooth. So the lithium and magnesium are harder than the other alkali metals and alkaline earth metals. The second group metals are called alkaline earth metals. And lithium, magnesium or slowly react with water. Slowly react with water. And their oxides and hydroxides are much less soluble. Oxides and hydroxides are much less soluble. And lithium and magnesium both are form nitrides. Lithium nitride and magnesium nitride. Remaining metals do not form that nitrides. And in first group of metals, lithium can form monoxide, and in second group of metals, magnesium can form monoxide, but the remaining metals cannot form the monoxides. Lithium can form monoxide and magnesium also can form monoxides. They can form monoxides and they cannot form the superoxides. On heating, carbonates of lithium and magnesium can form oxides and carbon dioxide. Lithium carbonate and magnesium carbonate. On heating, they can form oxides and carbon dioxide. But lithium and magnesium cannot form the hydrogen carbonates, means bicarbonates. Lithium bicarbonate, it cannot form. The lithium cannot form lithium bicarbonate, and magnesium also cannot form the bicarbonate. And lithium chloride, magnesium chloride, both are soluble in ethanol. And lithium chloride, magnesium chlorides are crystallizes from the aqueous solution as hydrates. That hydrates are lithium chloride 2H2O. It is a lithium chloride hydrate, and the magnesium chloride hydrate is MgCl2 8H2O. So the lithium chloride and magnesium chlorides are crystallizes from the aqueous solution as hydrates. Lithium chloride hydrate and magnesium chloride hydrate. So this is about diagonal relationship between the lithium and magnesium.